multiple things to do with break. All right. Reviewing here, I'm sorry. All we're doing is analyzing without a calculator. So you have to be able to graph this without being given a calculator. Is that something you feel confident in being able to do?
Sure.
Okay. The number one thing is to make sure that you understand that there's an asymptote for every exponential. Does anyone know where the asymptote is? It's at y equals 0. So you need to understand that there's an asymptote at y equals 0. Okay, the next part is when you're graphing to understand that your y-intercept comes from your a value. Your a equals 0, comma, your a. So I'm going to go to 0. In this case, it's going to be marked as 3, right?
Yeah.
0, comma, 3. Okay. And then I'm believing that they just want you to be able to sketch and make sure that you understand whether it's a growth or a decay. So in terms of what we have here, our B tells us whether it's a growth or decay. Do we have a growth or a decay? We have a growth.
But couldn't we say that if there's no negative in the equation?
No, your growth and decay depends on whether your B value is
Going up or down?
If your B is between 0 and 1, that's a decay. So now I have my sketch of what's taking place. And now I should be able to describe the limit. So the limit as x goes to positive infinity, what is it doing? Going to positive infinity. The limit as it's going to x goes to negative infinity, what is it doing? It's approaching 0.
It's like,
what's your boundary?
along the line.
Like, as your y values keep getting bigger and bigger, are they approaching something or are they going on forever?
Wait, so wouldn't it be, so everything or both?
No, because my y values here, they're getting closer and closer to what?
So it's going
0.
forever and oh, so
There
it's
you
gonna
go.
never get past to 0.
No, it's an asymptote, baby. So
So it never
stop
passed
it.
through.
That's its stopping point. It's like my goal is to
Wait,
be.
so why is it 0? It's approaching.
It's approaching 0.
Your
It's
limit is what's approaching.
what is approaching, not what it equals. Your limit is not necessarily what it equals. Your limit is what is it approaching? What is its goal? Okay. Your domain here is obvious. It's all real numbers from negative infinity to positive infinity. Guys, I'm sorry. I know I'm not the world's greatest teacher. I know I make 1,000 mistakes, but I do think I deserve like a class period where you're actually paying attention and actively learning the entire time, not just in moments. Your range. So your range here is 0 to infinity, and make sure that you use a parenthesis because it's an asymptote. Okay, it's not equal at that point. So I'd like you to take about 90 seconds to do what we did with example 6A to example 6B. Okay. I was looking for my
Payment is going down.
It's decreasing from left to right.
So it's. I thought it was going to be no, but look, we can take the. So we'll go to 0 then?
Your decay?
Yeah.
Why would it, what do you mean go to 0? Like it's a.
Oh, it's that one.
Yeah.
So does that mean that y is 0 to that?
All right, so here we go. Your A is your 5. So I'm gonna go to 5. This time my B is between 0 and 1, so I know it's a decay. It's still a an exponential function, so we know we have that horizontal asymptote. It's an exponential function in the form of a times b to the x. And because it's a decay, I'm going to go through and decrease. So now when I describe my limit, so as my function goes forever to the right, as x goes to negative infinity, what is it approaching? 0. My limit, as my function goes forever to the left, what it's approaching infinity. Okay. My domain is still negative infinity to positive infinity, all real numbers, and my range is still 0 to infinity, and that's because I have an asymptote at y equals 0. Okay. These are examples of non-calculator types of things you need to be able to analyze from an exponential function. Can you do this without a calculator? Okay.
So sorry. For number B, for letter B. For B, I thought it was only decay if B is smaller than 1 and bigger than 0.
It's 1/2. It's between. Is that 1/2? Your b is 1/2.
Your B is the number.
Your base of your exponential. It was 2.
That's your.
You're thinking of, so what we did was, to find our A value, we plugged 0 in and we got 3. So we plugged 0 in for X. And 2 to the 0 is 1 and 1 times 3.
Oh.
So A of 0.
Is whatever your a is.
Oh, I thought it was
That's like
just-
our Y-intercept.
I just thought it was just whatever's in the fix.
Your base.
That is.
Your b
So whatever's outside.
is your a, is your intercept.
But what
And A
determines it
equals
is your
5.
B. What determines whether.
This right here tells you whether you're a growth or a decay.
Oh, yeah. But then we just found 5.
5 is your initial, your intercept. All right, the last thing is being able to compare between linear and exponential models for a situation. So here you have Big Tex Industry has 25 locations and is expanding by is expanding by 10 new locations each year. The company growth can be represented by the function b of x equals 25 plus 10x. Central Computing Incorporated has 25 locations, and they expand by increasing their total locations by 40% each year. The growth can be represented by the function c of x equals 25 times 1 plus 4/10 to the x power. Complete the table to show growth of each company for the first 5 years. Okay, so it's saying over time, which company is going to have the, where they're going to be in 5 years. Now, the thing here is a lot of times, if you're only given 2 data points, we can misconstrue that the best model may be linear or the best model may be exponential. If you don't have that third additional point, your function may be skewed. Okay, and that's because initially, they can both appear to be the same. So this is an example of that. So notice here at 25 initially, plus year 1, I didn't add any. So that means I'm still at 25, correct? On this side, which is CX 25. And again, we're at year 1. I'm going to go ahead. Can I just add? Is that okay? I'm just going to write 1.4. That's okay with y'all. I'm going to write 1.4, and it's going to be to the 0, and anything to the 0 power is 1. Anything to the 0 power is 1. So we're initially at 25. So at year 0, they both have 25. Now we're going to do year 1. So year 1, this company is adding on 10, and now they're at 35. At year 1, we have 25 times 1.4 to the 1. And that also equals 35. Yes.
Since the 1 plus 0.4 are separate within the parentheses, wouldn't the x apply to both of them rather than it?
No, you simplify first before you apply your power. Parentheses. Okay. So do you see what I mean about only having those 2 can misconstrue the data, right? So when I continue, let's see if there's a difference in year 2. So in year 2, we're at 25 plus 10 times 2, which puts us at 45. On this end, we have 25 times 1 and 4/10 to the second power. And what does that put us at?
45.
49.
Oh,
Okay, so now this company has 4 more than this company with their 4% growth, 40% growth every year. So if we keep going, 25 plus 10 times 3, that's going to put us at 55. And we can quickly kind of do this one, right? It's going to put us at 65. On this side, we have 25 times 1.4 to the third, and we have 25 times 1.4 to the fourth. And what are our values? You can't, but I'm just going to write it so we can see the numbers. So approximately 68 stores, approximately 96 stores. So you saw nothing.
Can't round up.
I wouldn't either, but maybe the company would. Who knows? We're going to round up for the sake of the problem. Rounding correctly. Okay, so initially they were doing fine, right? They seemed to be growing at the same rate, but clearly Exponential is going to do what? It grows rapidly, right? It's going to increase a lot faster. And so when we say that you're given these 2 points and you have to determine whether it's exponential or linear, you have to be given a little bit more information. Otherwise, you may be making the wrong decision on whether it's exponential or linear. So that's why it's important to read the problem, because it may work for the first 2, but after that, there's going to be some change in the situation. Okay. So diving deeper, once we can graph and compare the 2 companies. Our initial was 25, right? So somewhere in here. And then 25 is going to go up to 30 over 1. Trying to do the linear as like accurate as possible. Y'all know I'm not the world's greatest drawer. What was 2? 45? I'm doing the linear first. 2, what was 3? 55. And 4 was 65. All right. I'm going to make the world's straightest line by concentrating. All right, so there's my linear. And this is for my b of x. Now I'm going to do my exponential. So exponential also started at 25, also ended up at 35, but then we made a jump, right? What was that, 2? 40 something, 49? A little bit more. And then 3 was at 68, 69, below this line. And then 4 was at 96. And so now it's doing this. So we can see the change in the growth. Okay. For both problems, the domain. So realistically, your domain and your range in a problem like this, your domain's going to start where in a real world model? 0. So in this sense of this problem, our x's start at 0, and then they're going to increase. We don't know where we're stopping. And we'll stop right there. That's the last part